All right, so this is a type of question from 7.4 that I would expect you could solve for the final. Again, it doesn't require a calculator to use. When you're solving an equation where not every term contains a log, what you want to do is move or condense all the logs from one side into a single log. So here I have these two log expressions. So when I condense them, any of the logs that originate from positive logs are going to be in the numerator of the single log. So this x comes from a positive, so it's going to be a factor in the numerator. The x minus 3 comes from a positive log. It'll also be a factor in the numerator. Since there's nothing that came from a negative log, there's nothing in a denominator here, so it's just what's left in this numerator. Okay, once you get everything written as a single log, so this is all over an unwritten 1, so I don't even really need this written as a fraction here. Once you get everything written as a single log, you're then going to rewrite it in exponential form. So in exponential form, we take the base of our log, which is an unwritten 10, to the power of whatever's on the other side, 1. Set that equal to what's inside the log, which is x times x minus 3. And then you solve the resulting equation. So it becomes a quadratic equation. We're going to go ahead and expand by distributing our x. We get x squared minus 3x is equal to 10. We now have this quadratic equation. It has more than one term that have a variable, so we need to move everything to one side and compare it to 0 or set it equal to 0. So we take our x squared minus 3x. All we have to do is move the constant over, so minus 10. And now we look to see, can we factor this? We have two factors of negative 10 whose sum is negative 3, of negative 5 and positive 2. So we have two possible values for our x. And when we plug these back into our original form, all you need to do is make sure that there's no negatives inside the logs or as the base of a log. So when we plug in a 5 here and a 5 here, neither of those become non-integers or non-whole numbers. So 5 works. But when we plug in a negative 2 here in either of these places, you wind up with a negative value in the log. So that's going to be an extraneous solution. So the only answer that works would be 5 for that.